Hey there, Algebra 2 students. Today I want to talk to you about 10.3. So we've got some two-way tables and some other fun stuff with probability. Okay, this just has to complete the two-way table. And the way we do that is subtraction, right, and addition. So if they tell you the total is 130 and you've got 60 on the city bus, you do 130 minus 60 to get 70, right? And if you do 130 minus 58, you get 72, right? Okay, well then 72 minus 22 would be 50. And 70 minus 22 would be 48. And 58 minus 48 would be 10, and that works because 50 plus 10 is 60. So that's a straightforward two-way table. Let's take a look at another question here. Survey was taken of 100 families with one child and 86 families with two or more children to determine whether they were saving for college. Of those, 94 of the families with one child and 60 of the families with two or more children were saving for college. Organize these results in a two-way table, then find and interpret the marginal frequencies. So I have sketched this table out. You can see we've got family size here, one child or two or more children, and saving versus not saving. So we know the total number of families with one child were 100, and then the two or more kids was 86, right? And so the total would be 186 families. They told us that 94 of the families with one child were saving, and 60 of these families were saving. And so if we add those up, we get 154. And so what remains, that would mean 6 families with one child were not saving, and 26 with the two or more kids were not saving. And so we've got our totals, 154, 6 plus 26 is 32, and 186 altogether. So we're supposed to organize the results and then find and interpret the marginal frequencies. So let's see, there were 186 families that were surveyed. 100 families with one child were surveyed. 86 families with two or more children were surveyed. 154 families are saving for college. 32 families are not saving for college. When they ask us to find and interpret the marginal frequencies, those are these things in the total columns and rows, right? And that's what we have done. All right, we'll do one more problem here today. For financial reasons, a school district is debating about eliminating a computer programming class at the high school. The district surveyed parents, students, and teachers. The results given as a joint relative frequencies are shown in the two-way table here. So we've got parents, students, teachers responding yes or no. And so notice I totaled everything below and to the sides there. So the first question they ask is, what is the probability that a randomly selected parent voted to eliminate the class? Well, how many parents total? So we add the 0.58 plus the 0.06, and we get 0.64, and so that's our denominator. And then we take the yes parents and put that in the numerator, and then we divide, and we get 0.906. Then we've got, what is the probability that a randomly selected student did not want to eliminate the class? A randomly selected student did not want. Well, how many students? That was 0.23 is their frequency, right? And the no's for the students is 0.15, so that's our numerator. And the 0.23 is our denominator, and we do the division there, and we get 0.652. And part C, it says determine whether voting to eliminate the class and being a teacher are independent events. The events are, in fact, independent because the probability of yes is 0.76, and the probability of yes given a teacher is also 0.76. So you take the probability of teacher and yes and divide by the probability of the teacher. You get 0.10 divided by 0.13, and you get 0.76, which is also the probability of yes. And so because those two are the same, the events are, in fact, independent. That is it for 10.3. I hope that you are well. We'll see you next time.